Hello, my name is Soumya Tripathy and I'm from Tampere, Finland. Our paper is single source one-shot reenactment using weighted motion from paired feature points. Recently, first order model and monkeynet-like models extended facial reenactment to non-face objects. The basic idea is to represent the face using key points and then learn the motion in the key point domain and apply it to image to get the reenactment done. The problem with this unsupervisedly learned key point is that they're forced to learn landmarks like features. Now in the cross reenactment setups, the landmarks like features also captures the facial shape information. Now, while transferring the motion from driver to source, they also transfer the shape information which distorts the source as shown here. The second problem is that each pixel in the generated image is dependent on its neighboring key points. So these key points are responsible for the generation of its neighboring pixels. Now any imperfection or error in this pixel or key point can lead to distortion around its neighboring pixels. So to simulate this, we added slight error on these key points and we can see the distortion here. To avoid this problem, we propose to unsupervisedly learn feature points on each image by attending the content of both the images jointly. So in case of key point based model like FOM, if we take a single source image, then the key points are always fixed because it doesn't depend on the driver. But in our model, the key points on both the images depend on each other. Even if it is a single image, it will continuously adjust itself depending on the driver. So you can see that the key points are changing. Now the second contribution is that we don't enforce the generated pixels to be dependent on its neighboring key points, rather that it depends on all the key points by a weighted representation. So we call it weighted motion. By combining the weighted motion and paired feature points, we developed our full model and we can extend it to non-face objects. And we can see here that our model preserves the source shape better than the FOM models or key point based models. Now, how do we do it? So in our model, the important block is the transformer that combines the source and driving images to predict the paired feature points. Now, once these paired feature points are predicted, then they are passed to a motion model. And this motion model is a moving least square based motion model. And this motion is then converted into warping field by a warping field generator like FOM. And this warping field is applied to the features of the source image to get the final reenacted output. Now the qualitative results show that our model preserves the identity and the facial shape of the source image better than the other state-of-the-art model, and it is very suitable for the cross reenactment. Now for the non-face objects, it is clearly evident that our model preserves the facial object identity better than the FOM. In all the cases, we applied it to Tai Chi and MGIF dataset. We also performed some quantitative evaluation on our model. We evaluated in ISIM, that is the identity, pose, and expression based metrics, and also the image quality based metrics FID. Now, within all the one-shot based model, our proposed method achieves the best identity metric, whereas in the pose and expression it is slightly inferior than landmarks based models, because landmarks produces better pose and expression metric, and our model has very few distortions, so the FID scores are better. Now this LPD model is here for the reference. This is few shot based, so there is a test time training involved. That's why they achieve very good ISIM score, but the PSIM and ESIM are bad because it mostly preserves the test time images, pose, and expression. Now to conclude, we proposed a novel paired feature point detector and a motion model to unsupervisedly extract the motion from the driver to reenact the source object. Now our feature point and motion model are shape and identity independent, and they are mostly applicable to the cross reenactment based model, and they perform the best there. Now we have shown experimentally that our model produces high quality reenactment output from single image by keeping the desired identity, pose, expression, and photorealism intact. Now we encourage you to check our supplementary video in our project page.